This video is just a brief introduction to the idea of an expected value.
Okay, hi everybody. So in this lesson we're going to talk about expected value, okay? And so expected value in some ways is kind of like looking at an average, maybe like a weighted average sort of thing. It's given an event and given the probabilities of the outcomes, what is it that you can expect to be the most likely outcome of a given event here, okay? So, for example, in the example we look at here to start off with is tossing a coin. So we look at the probability. Let's say you've got, we're going to look at, what does it say here? 4 different coins. When 4 coins are tossed, what is the expected or mean number of heads? So if you throw 4 coins in the air, on average, how many heads do you expect to see? Okay, so what we've got here, up above here, this is the probability. So the probability of getting 0 heads, you see it right here, getting 1 head is up here, 2 heads, 3 heads, and 4 heads. Now, later on in the course here, we're going to talk a little bit more about getting these probabilities here. For right now, you can think of it as what we did is we started here and built a tree diagram, heads, tails, heads, tails, heads, tails, and then just kept going here. Now this is quickly going to get onerous to do, right? Because we're going to have all these little branches here put together, but you can think of it like this. So what we did here is we found all the branches here, the number that had no heads, 1 head, 2 heads, 3 heads, 4 heads out of the total. Now, we get those probabilities. So assuming that we've got those probabilities here, now what we're going to do is we're going to put them in a chart. So here are my outcomes. Here's the number of heads, 0, 1, 2, 3, 4. And based on the chart that I have above here, that graph, I can grab the probability of each of those events here. Now, I'm interested in the average number of, or mean number of heads that we get. Well, let's take and multiply 0 heads by that probability, and what we're going to get here is 0. Then I'm going to take the probability of getting 1 head is 0.25, so the probability, I'm going to multiply the probability by the outcome, and I'm going to get 0.25. Then I'm going to take the probability of getting 2 heads and multiply it by 2 here. So 2 times 0.375 is going to be 0.75. Then I'm going to take the probability of getting 3 heads, which is 0.25. When I multiply that out, I'm going to get 0.75 again. And then the probability of getting 4 heads, have I been saying 5s? I think I have. The probability of getting 4 heads, though, is going to be 0.25. You're going to multiply 4 by that 0.025. So you take the event, the outcome, and you multiply it by its probability. Okay? And now what we're going to do is we're going to take and we're going to add up all of those probabilities. So we're going to add the 0.25 plus the 0.75 plus the 0.75 plus the 0.25. Okay? And when you add that all up together, that's what we call our expected value. Okay, so the expected value, E of x, can be calculated using the formula E of x. And now you'll notice, here we go, let's zoom in on that. You'll notice we got this funky little symbol here. Okay, that symbol right there is just a Greek, it's just a Greek letter, is all it is, but it means add up. So what we're going to do is we're going to multiply an event by its probability, and then we're going to add them all up. Okay, whoops, there we go. And that is going to be our expected value. And when we do that, when I add those all up, I get 2. So the expected, or the average number of heads that you expect to get when you throw those 4 coins up in the air is 2. Okay, on average, I will get 2 of them. Now, that doesn't mean that's always going to happen, and I hope everybody gets that. That does not mean that that is what will happen with every given event here. It just means that on average, that's what you're going to expect to see. Now, before we go on and do some questions related to this, what we have here is a random variable denoted by x is a measurable quantity which can take any value or range of values. Now, its value is the result of a random observation or experiment. So, like flipping a coin, okay? It can be heads or tails, okay? That is just a random occurrence there, and we just take a note of it. Now, actually, more specifically here, when we're talking about random variable, probably what we mean in this case here, it's a measurable quantity. So heads or tails, maybe not where they're going at with that. It's like the number of heads. After you've flipped the coin a few times, Okay, the number of heads you get is variable. It can take on a range of values. You just got to look at during the experiment and see what you get. The mean value of the random variable, okay, the mean value, that arithmetic mean there, if you want to think of it that way, is called the expected value of x, and it's written as e of x, and this is the formula that we use for the expected value. This is an incredibly important formula for statistics. Okay? In statistics, you're going to see a lot of the ideas that we talk about, like standard deviation, variance, whatnot, they're all kind of built off of this expected value and kind of ramping it up through different values of or different operations that we can apply to that variable. So it's the sum of the products of the values of the random variable and its corresponding probability. So we take every result, multiply by its probability, add them all together. That's the expected value. Okay? Or if you want to think of it again as another way of thinking about it, just to help you out with that, it's the mean. Okay, so let's walk through an example here when we're talking about expected value. So we're going to be drawing marbles. So a bag contains 3 red marbles and 7 green marbles. Okay, so we've got 10 marbles in there. Okay, so 10 total, and we've got the 3 red, 7 green. 2 marbles are drawn at random without replacement. So we're pulling one out, putting aside, pulling another one out. Now, we're going to use the following probability tree to represent the possible outcomes. So we could get a red, or we could get a green. So now the probability of getting a red here is going to be 3/10, and the probability of getting a green is going to be 7/10. So it helps me just to write that out next to those branches here, so I have an idea of the probabilities as I move forward here. Now, if I've drawn 1 red and put it aside, that means I'm 1 red short. So there's only 2 reds left for that second draw, but there's only 9 marbles left after I pulled that first one out. So the next probability here of getting that red is going to be 2/9. Whereas the number of greens hasn't changed, so it's still 7, but still the total number of marbles has changed. It's gotten 1 less because of that red that I pulled out. Because remember, I'm assuming that this event occurred, and now I got to think, how does that affect the next event? Down here, I'm assuming that the event has occurred where I've chosen a green. So the number of red in there is still going to be 3, and this time there's 9 marbles left over, so I've got this 3/9. Now I could simplify that, but in a little while here, just looking at this, I'm thinking that I might want that 9 back in there, just to make sure I've got common denominators going down. If I've got green here, that means there's 1 less green, so it's going to be 6. And in this case here, again, we're still short 1 marble, so it's going to be 6/9. Now, multiplying through, determining the probability of each of these events, let's zoom in here a little bit, I'm going to get 3/10 multiplied by 2/9. Now, just to make this really straightforward, I'm going to leave the numbers the way I'm going to get them here. So it's going to be 6/90. This is going to be 21/90. This is going to be 21/90, and down here, this is going to be 42/90. Now, interesting thing here, if we take 6 and we add 21, and then we add the 21, and then we add the 42, we get 90. So when you add up all those probabilities, the result is just 1. So this really covers all of the different possibilities here. There's nothing that's being left out. So now let's complete the table below, where X represents the number of red marbles. Okay, so let's think about what this means here. If we're talking just about the number of red marbles, this is 2 red marbles. This together here, okay, oh, that did not come out as like what I wanted there. This is going to refer to 1 red marble, and down here this is going to be no red marbles. So the probability of getting no red marbles is going to be 42 out of 90, and yes, I can simplify that, but I'm just choosing not to right now. The probability of getting 1 red marble is going to be the sum of those two. 21/90, 21, well, that's going to be 42/90. Isn't that interesting that that's the same? Over here, the probability of getting 2 reds is going to be 6 out of 90. Now, let's find the expected value, because now that I have the probability of each event, and I've got that event here, what I can do is I can add those all up. So the expected value, okay, the expected value for that variable x, and x can take on one of these three values here, either 0, 1, or 2, is going to be 0 multiplied by 42/90ths plus 1 multiplied by 42/90ths plus 2 multiplied by 6/90ths. Okay, so 42 plus 12 over 90, and I'm going to get 54 over 90. Okay, so now would be a really good time for us to start talking about simplifying. And I can, at first glance here, I see that 54/90ths, I can divide both of those by 9, and I'm going to get 6 over 10. And I can go actually one step further, although that's a nice number for me to work with because I know that the answer is going to be 0.6 if I want to write it as a decimal. This is going to be 3/5. So that's the probability that I'm going to, sorry, that's not the probability. Wow, I said that wrong. That is the number of red marbles that I'm expecting to grab. Okay, the expected value, the anticipated number of red marbles that I get when I draw 2 out is 3/5. It doesn't make a whole lot of sense, but that's okay. This is just saying that that's what happens on average. On average, okay, I'm expecting to get less than 1 red marble, is basically what that's saying. Okay, it is far more likely that when I grab 2 marbles out, I'm going to get greens. That's what that's trying to say. Okay, let's take a look at one more question here. Since it's a random variable, can only take on the values of 1, 2, and 3. Okay. Then we're told that the value of 3 is twice as likely as each of the values of 1 and 2, and the values of 1 and 2 are equally likely. Okay, so let's just get our heads wrapped around this. So I have to fill in this probability chart here, but I wasn't given the probabilities. I do know, okay, and I'm going to use just a little variable in here. Let's say I do know that the probability of A, let's just call it, sorry, A. I know that the probability of 1 is, I don't know, let's call it A. So the probability of 2 is also going to be A, and I'm going to put little equal signs here because I'm hoping that in a second here I'll figure out what that is. And then we're told that the probability of 3 is going to be double that, so it's going to be 2A. Now, this is what the information that I've been given here. The bit of information that you need to bring to the table on this one is that if you add up the probabilities of all the events, okay, assuming you've got all of them, the answer should be 1. So altogether, what have I got here? I've got 4 A's. So A is going to equal 1/4. Okay, so the probability of the 1 showing up is 1/4. Of 2 showing up is going to be 1/4, and then the probability of 3 showing up would be 2/4 or 1/2. Now I'm set up to find the expected value, okay? Because the expected value is going to be the result multiplied by its probability, plus the result multiplied by its probability, and once again, the result multiplied by its probability. So I'm going to get 1/4 plus, well, 2 times a quarter is going to be 1/2, plus 3/2. Okay, so now let's think about this. I'm likely going to have a common denominator here, 4, and normally I wouldn't just do this here, but every once in a while I get questions about this. So remember, this is going to look like this. It's going to end up being 2/4, and this is going to end up being 6/4. Okay, I got to multiply numerator denominator by 2, numerator denominator by 2. Now, over 4, add the numerators together, and I get 9. So 9/4. Now, right off the top, that might not make a lot of sense. Like, what the heck are we talking about here? But what this means, this might help to think of it this way. What this means is that the expected value here is 2.25. If I write it as a decimal, that might make a little bit more sense. Because now what we're saying is on average, I expect the value of the variable that I'm getting to be somewhere along this lines, somewhere around here, right? It's a little bit more than 2, okay? Not quite full on 3 here, but it's here's 1, here's 2. It's just that the value of the variable here seems to be weighted a little bit more towards the 3, so it's pulling it up above that. And that's what that's saying. So on average, if we do this over and over and over again, and then we add up all our results, divide by the total, we're going to get 2.25.